Hello guys, gals, and pals. Today we will be going through my linked list project. This is my main method here. I just hard-coded a bunch of values. Nothing really that interesting going on in here. This is my LL node class. Um, I have a default constructor just because I like to have one. And then we have two public data values, or properties. We have data as an integer, and then our reference to the class, which is known as next. And then we have the constructor, which we will be primarily using, which it gets a integer value passed to it, so that every time it's constructed, it has these values. And then when we get to the linked list class, scroll up. At the very top, we have a reference to the node class, which we call head. So we initialize a head node. And then on construction of the class as an object, we initialize the head as a null. So when it came to adding to the list, I made a prepend and an append method, however you want to say that. I started with this one because I was watching some videos on how to do it, and that's how they did it. And I was like, well, I don't like prepending, I like to append stuff, so I went ahead and made both. So prepend, we create an object out of the node class, so we just make a node. And then we point that node to the head value, and then we assign the new node, or the head, the new node's value, so you're always prepending the list. And then in the next one, for the append method, I think that's how you say it, we initialize the current node, or we make a current node object and initialize it to the head node. And then we make another node object here, so we're just making a new node. And then if the list is empty, we assign the node to the head value, so that's our new head node. Otherwise, we will traverse the list, and then while the current node is not equal to null, we leapfrog through the list. That's how I like to think of it. Anyway, it makes me smile. And then as soon as we reach the tail of the list, we assign the current node that new value, or the pointer that new value. The delete method is probably the one I had the most trouble with. Let's see if I can refresh my memory. Initializing current node. Okay, so we initialize the current node to the head value as with any method. This is just in user feedback, so when you run it, you can see which method you're on. So this is our head check to see if the first node that we're trying to remove is from the head. So if the head is not null, and the current node is equal to the key value, which is the value that we want to remove, we overwrite the head node value with the pointer's value, and then we inform the user of what happened. Otherwise, the list is just empty. So that's our head check. And then if it's not the head, we just loop through the list like with any other method. And then if the current node's next data value is equal to the key, we overwrite that next node's value or the pointer value with the successive pointer value. So we remove that value and we shrink it back together. And then we inform the user that the node has been removed, and then we reprint the list to show that it was removed. The search list was probably the simplest and the most fun to make, I thought. So we receive a key as a method argument or parameter. I always get those two confused. Reinitialize current node to head, so that's our starting point. Inform the user of what we're doing, and then we loop through the list, and if the current node's data is equal to the key, we print the list, we say we found your value, and then we break out of the loop. And this is just moving the current node along on each iteration. And then if the value is not within the list and we reach the tail end of the list, then that current node will be null, and then we'll just write that it has not been found. And then the print list, initialize the current node to the head as always. And then we just loop through it, and then on each pass we format the node like this, and then we leapfrog along the line until we get to the end of the list, and this is just to make a line at the end of the or a new line or a blank space at the end of the output. So let's run this and see what we get. Oh, well, first let's close out of that. Close. Thank you. And we'll go through here and we'll just see the hard values that we're getting first. So we prepend 5, 8, 1, 94, 23, and 14, and then we append 20 at the end. Then we print the list. We're going to search for 94, and then we're going to delete 14 from the list, which is going to be our first value. And then we're going to delete something from the middle just so we know that both methods or both functions in the method are working properly. So let's run this now and see how it works. And as we can see, let's move this to the side. We are prepending the list, so we got 5, 8, 1, 94, 23, 14. We append 20 at the end. We search for the value of 94 and we find it. We search for 14 and we remove it, so that's gone. And then we search for 94, we remove that, and that's gone. So that is my project. Any thoughts, questions, comments, or concerns? Comment on my post. Thank you.